Alrighty, today's video, theoretical probability of compound events. The first thing we need to look at is, by definition, what is a compound event? A compound event is any event that consists of two or more simple events. And we've already discussed what a simple event is, which would be like rolling one dice or flipping one coin. A compound event would then be flipping two coins or rolling two dice. So for our first example, we're going to look at rolling two dice. So this here is called a sample space. So this is what we're going to use to list out the outcomes for rolling two dice and finding a particular sum. And we know sum is addition, so we're rolling two dice and adding the two numbers together. So first, let's fill this out. So go ahead and fill this out with me. Oops. All right, so we've got my sample space filled out. So the first thing we need to figure out is how many possible outcomes there are. And if we count up each individual square that we filled out, we see there are 36 outcomes here. And we can also figure that out by knowing that there are 6 outcomes in one simple event, so rolling one dice, and 6 outcomes in the other simple event, rolling the second dice. And we know that 6 times 6 is 36. So essentially we take the number of outcomes in each simple event and multiply them times the other simple events in the total compound event, and that's how many outcomes we have. So now I'm going to circle how many times I have an outcome of 8. And I see here that rolling a sum of 8 shows up 5 times. So there are 5 ways Therefore, the probability of rolling a sum of 8 is 5, which is the number of ways the outcome occurs, out of the total 36 possible outcomes. And we can turn that into a percent and say that we have a 14% chance of rolling a sum of 8 if you were to roll 2 dice. Now the second example we have is another way that we can use a sample space for visually showing or calculating the number of possible outcomes in another compound event, and that is called a tree diagram. So some of you may be familiar with a tree diagram. All right, so let's list out how many outcomes we have here in this example. So it says a deli prepares sandwiches with one type of bread, white or wheat, one type of meat, ham, turkey, or chicken, and one type of cheese, cheddar or Swiss. Each combination is equally likely. Find the probability of choosing a sandwich at random and getting a turkey and Swiss on wheat. So this is really what we're going for. Before we can figure that out, we need to figure out how many total outcomes there are. So a tree diagram starts out by figuring out the first option we have is white or wheat bread. And then after we choose our bread, we have our meat choice. And I'm going to abbreviate. So I can choose ham, turkey, or chicken. And after I choose my meat, then I choose my cheese. So I've got cheddar or Swiss, cheddar or Swiss, and again, cheddar or Swiss. So if we note here, we have white ham and cheddar, white ham and Swiss, white turkey cheddar, white turkey Swiss, white chicken cheddar, and white chicken Swiss for total outcomes. Just by choosing white bread, 6 outcomes. But then we also have where we can choose wheat bread instead. So again, we have choosing ham, choosing turkey, or choosing chicken. And then we have our cheese options, cheddar or Swiss, cheddar or Swiss, cheddar or Swiss, for another 6 outcomes with choosing wheat bread, for a total of 12 outcomes here. So we have 12 possible outcomes, and now I want to look at how many times I could choose a turkey and Swiss on wheat bread. So I know it's out of 12. So I'm not even going to look at this section where I have white bread because I'm really focused on wheat bread here. So wheat bread, I can choose turkey and Swiss. Only one time does that occur. So out of the 12 possible outcomes, there's only one that fits the criteria of choosing turkey and Swiss on wheat. So 1/12. So now what I'd like you to do is turn this over and work on the Your Turn questions. There is a key word on the very first Your Turn question, and that is product. So make sure that you're very familiar with what the term product means before you fill out that sample space.